अभिभाषण के अध्यक्ष चेयरपर्सन डॉक्टर सुधीर कुमार सुपोरी जी, भूतपूर्व कुलपति जवाहरलाल नेहरू विश्वविद्यालय एवं एमरिटस सीनियर साइंटिस्ट इंटरनेशनल सेंटर फॉर जेनेटिक इंजीनियरिंग एंड बायोटेक्नोलॉजी न्यू दिल्ली, हमारे साथ हमारे बीच में जुड़ चुके हैं। स्थापना दिवस अभिभाषण के वक्ता डॉक्टर संजय कुमार जी, कृषि वैज्ञानिक चयन मंडल के चेयरमैन, हमारे साथ जुड़ चुके हैं। साथ में हमारे पूसा संस्थान के निदेशक डॉक्टर अशोक कुमार सिंह जी, हमारे भूतपूर्व निदेशक डॉक्टर एच.एस. गुप्ता जी, संयुक्त निदेशक प्रसार डॉक्टर आर.एन. पटारिया जी, संयुक्त निदेशक शिक्षा एवं अधिष्ठाता डॉक्टर अनुपमा मैम, संयुक्त निदेशक अनुसंधान डॉक्टर श्री विश्वनाथन जी भी हमारे साथ जुड़ चुके हैं। मैं सभी विद्वजनों से आग्रह करता हूं कि हमारे साथ मंच पर जुड़ें। डॉक्टर सुधीर कुमार सुपोरे जी, डॉक्टर संजय कुमार जी, डॉक्टर अशोक कुमार सिंह जी, डॉक्टर आर.एन. पटारिया जी। भारत की परंपरा रही है कि हर शुभ कार्य से पहले हम प्रकाश को धारण करते हैं, दीप प्रज्वलन करते हैं। मैं स्थापना दिवस अभिभाषण के अध्यक्ष डॉक्टर सुधीर जी, डॉक्टर संजय कुमार जी, हमारे निदेशक डॉक्टर अशोक कुमार सिंह जी, डॉक्टर आर.एन. पटारिया जी को निवेदन करूंगा कि दीप प्रज्वलित कर इस कार्यक्रम का शुभारंभ करें। शुभम करोति कल्याणम आरोग्यम धन संपदा शत्रु बुद्धि विनाशाय दीप ज्योति नमोस्तुते, दीप ज्योति नमोस्तुते। स्वागतम है आपका, आगमन है आपका, जिस चमन के फूल हम वो चमन है आपका। मैं पूसा संस्थान के निदेशक डॉक्टर अशोक कुमार सिंह जी से अनुरोध करूंगा कि हमारे अध्यक्ष डॉक्टर सुधीर कुमार सुपोरी जी को पुष्प गुच्छ भेंट कर हमारा प्रेम, हमारा आभार उनके प्रति व्यक्त करें। पुनः निवेदन रहेगा डॉक्टर अशोक कुमार सिंह जी से कि स्थापना दिवस अभिभाषण के वक्ता डॉक्टर संजय कुमार जी को पुष्प गुच्छ भेंट कर हमारा प्रेम, हमारा आभार उनके प्रति व्यक्त करें। हमारे बीच हमारे भूतपूर्व निदेशक डॉक्टर एच.एस. गुप्ता जी भी हमारे साथ सभागार में जुड़े हैं। मैं अनुरोध करूंगा डॉक्टर अशोक कुमार सिंह जी से कि एक पुष्प गुच्छ सर को भेंट कर हमारा प्रेम, हमारा आभार सर के प्रति व्यक्त करें। बहुत बहुत धन्यवाद सर। आजादी के बाद जब खाद्यान्न का संकट उभरा था, भूखे बच्चों को सरपट सोते देख जब मुरझाया हर मां का मुखड़ा था, तब इसी भूमि से डॉक्टर एम.एस. स्वामीनाथन जी ने इतिहास का रुख मोड़ा था। बौनी और अर्धबौनी किस्मों में हमें हरित क्रांति से जोड़ा था। उसी स्वर्णिम इतिहास की चिति एवं थाती ले यह संस्थान निरंतर बढ़ता है। किसानों के भाग जगाने अनुसंधान के नए आयाम गढ़ता है। पूसा बासमती की तरह महकता है, पूसा अल्पना की तरह खिलता है। मल्लिका आम्रपानी का रस समेटे, पूसा सरसों का रंग लपेटे, ये हम सबके दिलों में धड़कता है, ये हम सबके दिलों में धड़कता है। आप सभी को पूसा संस्थान के स्थापना दिवस कार्यक्रम 2024 में बहुत बहुत स्वागत, बहुत बहुत अभिनंदन। आज का दिन गौरव का दिन है, उत्साह का दिन है। आज का दिन यह महसूस करने का दिन है कि हम उस संस्थान से जुड़े हैं जो भारत रत्न डॉक्टर एम.एस. स्वामीनाथन जी, पद्म भूषण डॉक्टर वी.एल. चोपड़ा जी, पद्म भूषण डॉक्टर आर.एस. परोड़ा जी, पद्म विभूषण डॉक्टर बीबी पाल जी, पद्म विभूषण डॉक्टर आर.बी. सिंह जी जैसे महानायकों की कर्मस्थली रहा है। हृदय धड़कता है, रुधिर चमकता है, मस्तक ऊंचा होता है जब हम एहसास कर पाते हैं कि हम उस संस्थान से जुड़े हैं जिसने विश्व को 4 विश्व खाद्य पुरस्कार विजेता भी दिए हैं। 860 से अधिक फैकल्टी, 26 विषयों में 11,000 से अधिक डिग्री प्रदान करने वाला, गेहूं के कुल उत्पादन में 60 मिलियन टन का योगदान देने वाला, बासमती के टोटल फॉरेन एक्सचेंज में 90% का योगदान देने वाला, कृषि क्षेत्र में NIRF रैंकिंग में सर्वश्रेष्ठ पायदान में खड़ा यह संस्थान निरंतर कृषि के अनुसंधान क्षेत्र में प्रसार में कार्यरत है। मैं संस्थान के निदेशक डॉक्टर अशोक कुमार सिंह जी को स्वागत उद्बोधन एवं आज के स्थापना दिवस अभिभाषण के अध्यक्ष के परिचय हेतु आमंत्रित करता हूं।
आप सभी लोगों को भारतीय कृषि अनुसंधान संस्थान के इस जन्म दिवस के अवसर पर मैं हार्दिक बधाई देता हूं। We have with us today Professor Sudhir Kumar Sapori, chairperson of this important program, and the speaker of today is Dr. Sanjay Kumar, who is chairman of ASRB. Also, we have august presence of Professor H.S. Gupta, former director IRI, Professor Anupam Verma, former dean, Dr. Rasmi Agrawal, former dean, Dr. A.K. Singh, former project director WTC, my colleague Dr. Ravind Padaria, Dr. Viswanathan, Dr. Anupma, Dr. Brahmanan, and director of Indian Agricultural Statistics Research Institute, Dr. Rajendra Prasad, who is with us, Dr. Gyanan Singh, Director IIWBR, who is one of the hubs of IRI for the education program, all the distinguished faculty members, professors, heads of the divisions, students, farmers. On this very important occasion, once again I would like to congratulate each one of you for your gracious presence here and being part of this celebration. This year we have had a very successful year for the Institute in terms of significant achievements. Few of them were highlighted by my colleague, Dr. Gurjesh Mehra. During 23-24, we had about 25 varieties of field crops and 42 varieties of flowers, fruits, and vegetable crops which were released for commercial cultivation. We had a special attainment in the area of basmati rice, and this year basmati rice export touched 45,000 crores, 5.5 billion US. Imagine the total agri export from country is $50 billion, and out of that $50 billion, $5.5 billion, more than 10% is coming from single commodity, and the contribution from IRI in that development of basmati varieties is more than 95%. We have developed some early varieties of paddy, which has been a major concern because of paddy straw burning in northwestern plains of India, particularly Punjab, Haryana. Two rice varieties, Pusa 2090 and 1824, have been developed which mature in just 120 days seed to seed, with a yield almost at par with Pusa 44, which used to take about 155 days. And because of that, there was a major problem of paddy straw burning, because after harvesting paddy, there was no time left for wheat sowing, and people used to go for burning. So these two new varieties will bring a revolution, and also in basmati segment, we have got quite a few new varieties which are early segment, 1509, 1847, 1692. And moreover, we have also come out with two herbicide-tolerant rice varieties, which will be boon for shifting transplanted rice cultivation to direct seeded rice, because weed has been a major problem, and through these herbicide-tolerant rice varieties, it should be possible to promote direct seeded rice in this part. The varieties were released 2 years back, but we were stuck up because of the clearance, the expansion of label claim for this herbicide to be used on rice, which fortunately has now happened just few days back, and notification once it comes from this year, we will have a large area planted to these ST varieties. In case of wheat, as we know that IRI contribution is almost 50 million tons to nation's granary, and 10 million hectare area is planted to IRI varieties, and a number of new improvements over the existing varieties 2967, 3086 have been made, and variety 3386, which is very high yielding, almost 10% higher yield than 2967, has been released. An improved version of 2967 with resistance to yellow rust has been released, which has become a problem in this particular variety. In maize, we have made a major breakthrough where we are working on developing varieties, hybrids in particular, which are suited for bioethanol production. We know that by 2025, the government has a target of 20% blending of bioethanol in petrol, and this will require about 1,500 crores liters of bioethanol. And to meet that, one of the major areas of research focus is diverting maize for bioethanol production, and for that special breeding efforts are required because the recovery of bioethanol from the current day hybrids is just 10 to 11%, which is not economically viable and sustainable. This has to be improved to almost 14 to 15% to make it comparable to that of rice. Currently, a lot of rice, broken rice was going into bioethanol production, which has been stopped by government because of food security reason. So now the new hybrids, which our group, Dr. Firoz Hussain, has developed, waxy hybrids and others which have got about 40% bioethanol recovery, that will be a major breakthrough. Genome editing has been a major area where Institute has made a very important breakthrough, and Dr. Viswanathan has developed two varieties in the background of MTU 1010, which have been genome edited for drought and salt tolerance trait, and they are in the national trial. First year trial is completed, and one more year testing is required before these are released. ICR has also invested hugely, almost 500 crores given for genome editing in different crops. Out of that, about 350 crores comes for the crop-related genome editing work. And almost 25 crops and 25 institutes have been identified with IRI as the lead center. So also in terms of education, IRI has, as you all know, started the UG program. And currently, we have got about total enrollment of 2,687, with UG number being 717 and PG 585 and PhD 1,385. We have now 16 hubs of IRI associated in different cities, and they have started UG program, PG program, and some places we have got PhD program. IRI Assam and IRI Jharkhand, both places, now we have got fully functional laboratories, teaching program, faculty, and recently Honorable Minister of Agriculture has inaugurated the hostels and the main academic administrative building at IRI Assam and IRI Jharkhand, both. At IRI New Delhi also, the hostel capacity has been increased with inauguration of Madhumas with 500 beds hostel for boys, and Falguni, a girls hostel for 500 beds. So with this, I think we will move towards making IRI a global university. It requires a lot of efforts, and I'm thankful to all our hub directors for taking keen interest. Dr. Gyanan Singh, thank you so much, and all those who have joined online. But for your participation and keen interest, this would not have been possible. And also thanks to our Director General and Secretary there, Dr. Himanshu Pathak, for initiating this program in a very meticulous way that we are able to implement it. Now, with that brief, mention about the significant achievements of the Institute, I would like to introduce the chair of today's function, Professor Sudhir Kumar Shipori, a very distinguished scientist who is currently Emeritus Scientist at International Center for Genetic Engineering and Biotechnology. He did his bachelor and master's from Jammu and Kashmir University and PhD from University of Delhi. And he was postdoctoral fellow at USDA Maryland, University of Texas, and Max Planck Institute. Visiting Humboldt professor at University of Munich, Germany. Served as assistant professor, then rose to associate professor and professor almost more than 20 years at Jawaharlal Nehru University, and also as a group leader of plant molecular biology at International Center for Genetic Engineering and Biotechnology. Also served as vice chancellor of Jawaharlal Nehru University, and he has been awarded Doctor of Science Honoris Causa by Banaras Hindu University and Rani Durgavati Vishwavidyalaya, Jabalpur. He is fellow of the World Academy of Sciences Italy, and also fellow of all the 4 science academies of India. Professor Sapori is also awarded with prestigious Santi Swarup Bhatnagar Award and also Padma Shri by Government of India for his distinguished contribution and service to nation, serving the society through science. His major research focus has been on understanding mechanism of abiotic stress tolerance in plants, and his group has revealed the role of different genes and more specifically glyoxylate pathways in stress tolerance, crosstalk between different stresses and light responses in regulating the expression of genes, including regulation by microRNA, and currently his group is working on understanding the molecular basis of stress priming mediated responses and stress memory. Has more than 250 papers published in very reputed journal. We are indeed thankful to you, sir, for agreeing to our request to chair this session. Once again, I would like to welcome you and all of you on the occasion of the Foundation Day of IRI. Thank you very much.
Thank you so much, sir. With welcome address, you also highlighted the landmarks achieved by our institute. Now we have a very short film on the institute achievement and new initiatives taken during the last 1 year. We will wish to share with you a glimpse of Foundation Day celebration 2024. I request our technical team to kindly play the video. Thank you all for your kind attention. Now I request Dr. Sudhir Kumar Sopori sir, the chairperson of today's program, to kindly introduce the learned speaker of Foundation Day lecture, Dr. Sanjay Kumar sir. Sir, please.
Dr. A.K. Singh, Sanjay Kumar, Dr. Padaria, Dr. Gupta, Anupam Verma ji, many other former deans, faculty members, students, ladies and gentlemen. It's a really great honor for me, and I feel really happy to be part of this Foundation Day celebration of an institute like IARI. The contributions of this institute you have just heard from Dr. A.K. Singh and also from this which was displayed just now are immense, and I don't think I'm going to get into this. My simple task for this is to introduce the present speaker. When Dr. Padaria called me that, would you like to participate? You have to come as a chair of this session. And I said, who is the speaker? He said, Dr. Sanjay Kumar is the speaker of this one. He said, do you know him? I said, I don't know how much I know him. He said, I will send you his CV for introduction of Dr. Sanjay Kumar. And this is the one-page long CV I received. This is also an abridged version of his CV, which I received when I was coming in the car this morning. It's such a pleasure that we'll be listening to Dr. Sanjay Kumar about the work he has been doing at IHBT and in many other ways he has contributed in this country. Most of you know him now as chairman of Agriculture Scientist Recruitment Board, a job which he has recently taken up. But he's a product of this institute, did his PhD here. And I know him since those days. So it's almost like 40, 45 years of association with Sanjay. I take this privilege of calling him Sanjay by his Professor Dr. Sanjay Kumar. and known how he has worked so many years in different segments and made great contributions. He had his initial training also at Texas Tech University, Rothamsted, he was there, Kansas State University, and finally he landed at the foothills of Himalaya at Palampur, and where he continued for almost like 35 years or something, which he contributed right from the initial stages of being a scientist and becoming the director of that institute. Has been a long journey, something where he has really worked very hard, right from the laboratory science which he did, as also the application work which he did later on even as the director of the institutions. He has made various contributions in the area of plant physiology, plant biotechnology and other areas, and I have been following up on his work. His major novel carbon fixation pathway which he discovered in high altitude plants, alternate oxidase system which was there, is a landmark discovery in plant physiology research. He is also, I remember the excitement was there that superoxide dismutase which was discovered from his laboratory at IHBT, and this is an enzyme which can tolerate autoclaving. And when I was the chairman of their research advisory committee for almost like 6 years, and not during his tenure as a director, but earlier than that, and we were all surprised how an enzyme can tolerate 100 degrees centigrade or autoclaving. But later on when they did the whole structure of this protein through at ICGB, they took some help, and they published that piece of work, suggested how a protein like SOD could also be is possible for them to tolerate very, very high temperatures. His work on plant microbe interactions, nutraceuticals using traditional knowledge has been very well appreciated all over. But he's also done very fundamental work in the area of genomics, the transcriptomic work which he did of many Himalayan plants and genome analysis of these Himalayan plants which he has done, relation to cold accumulation, cold tolerance and other physiological parameters. Recently when I visited their Foundation Day lecture or something, I went to the laboratories and I was very much excited to some of the work which they are doing on the rose development. And this is the development of thorn which comes in the rose. You know, rose has thorns. So what is the mechanism by which these thorns are developed? And this is the one which they finally published a very good paper and was an exciting research discovery, and also his work on tea. And they have developed a major tea manual from IHBT. I'm giving you a little more details because they have given me 10 minutes for this, otherwise I would have been a little shorter. So, but this is worthwhile knowing from younger generation that the kind of work which he has done in last 30, 35 years and produced almost like 30 MSc, PhD students and trained a dozen of workers and published his papers in more than 200 publications of high impact journals and many contributed to many chapters in many books. Sanjay is a fellow of INSA, NASI, NAS, Crop Development Society, all the societies which is there, and has received many, many awards. A few which come to our mind, Vasvik Industrial Research Award, INSA Young Scientist Award. So INSA Young Scientist Award is given just immediately after you do your PhD. वो कहते हैं ना शुरू में पता चल जाता है किसने कहाँ पहुँचना. Even at that young age, he got that INSA award, and his contribution for his PhD research, which he did with Dr. S.K. Sinha, was something which was recognized by Indian National Science Academy at that time. He has got R.D. Asana Endowment Award, G.V. Joshi Memorial Award, Ranjan Memorial Award, Essential Oil Industry Outstanding Alumnus Award, and many, many more awards which has been there. But what impressed me most, I have been visiting IHBT, Dr. Verma has been visiting there, is the kind of innovative ideas which he brought in forth when he was the director of that institute. And took many initiatives which was not only in terms of improving your basic fundamental work, but how to transform this work which will benefit the farmers and society per se. And that is where one of some of the major contributions which came from him, especially in the cultivation of saffron which he did. They were trying to cultivate saffron, apple. IHBT, I don't know, many of you may not know, maybe we'll mention about it. I don't want to predispose. He has sent it to northeast area where apple cultivations are being done, cinnamon, lilium, tulips, which are now grown there. And one of the things which was also this monk fruit. I've seen that one. When they brought it from China and started cultivating, I went to those gardens and saw that how they are trying to grow and will be improving these new agriculture products in this one. And he has developed a lot of entrepreneurial development programs, MOUs with industry. This is what we all talk about, that you must develop these MOUs, transfer the technologies, which IHBT and his own laboratory has transferred a lot of technologies, which are, it's not just a transfer of technology, but the products are now being sold in IHBT, in Palampur area and many other areas. In fact, in Palampur, I went once, there is one Mahatma there, you know, and when we went there to see him, he said, what are you all produce here? So Dr. Sanjay Kumar said that these are the areas. He said, in my next occasion, you must display here everything, because thousands of people come on Guru Purnima in his ashram. So put up a stall there, let me see what all you produce. And they were so nice, this IHBT under his direction. The stall was put, and hundreds of people came and visited that stall from IHBT. So I would briefly say that last 35 years of his trajectory of research has proven that a person coming from IRI, how he can lead an institute in CSIR. And that is the long journey which he has covered. It's such a pleasure that we'll be all listening to this journey of IHBT and journey of Sanjay. I think both these have come together. The institute and Sanjay, they have grown side by side in this institute. Thank you very much, and we look forward to your lecture.
Thank you so much, sir. You have given a brief but brilliant introduction of our eminent speaker. Now I would like to request Dr. Sanjay Kumar Singh, sir, Chairman ASRB, for our Foundation Day lecture. Thank you, sir.
Honorable Professor Sapori, Dr. Singh Saab, Director of this prestigious institute, Dr. Padaria, Honorable Professor Anupam Verma, with whom we have been always interacting time and again, even at Palampur, because he has his residence at Palampur, so we always have very good chance to learning from him time and again. In the hall, it was so pleasant to see Professor Gupta, Dr. A.K. Singh, Dr. Deshmukh Saab, Dr. Gyanenji, and I could see Professor R.B. Singh Saab on the, I think he is attached online, and all those attached online, and all the staff members, all the students. It's such a great honor when Dr. Singh told me that you had to deliver the Foundation Day lecture of the institute where you have been the student. And when we understand the definition of alma mater, I think IRI is the real example of that. It's a nourishing mother, not only to all of us, but to the whole nation. So many congratulations, and I feel so honored to be presenting the Foundation Day lecture of this great institute. And there are several reasons. Not only that I feel myself blessed. You know, when I started my scientific career from Pantnagar, I had a chance to be in Professor Sapuri's lab for 28 days. And at that time, my first exposure to SOD took place in his lab. Although I was working on calmodulin, but that was my first short exposure to SOD. And I did not know that I'll in future work on SOD, that enzyme. And I'll tell you how we started working on that enzyme later on. But just wanted to share with all of you that that is the power of a lab which can transform. That is the power of a teacher which can transform. And this is the power of the institution which can transform the individuals, the labs, the nature of science, and the nation. So I was so blessed that I had a chance to be in his lab. Then at IRI with Professor Sinha as my teacher, who would compromise on nothing but for the excellence. He would always say that if something has already been said, what is new that you guys are going to do it? So he will never ever encourage us to repeat the work which has already been done. Always he talks of new concepts in science. And that thing I learned from him, that whenever we had to do something, we had to do something differently, otherwise there is no fun of doing anything. So we had a fantastic training at IRI, and apart from that, I had certain good experiences also from this particular hall, and I'll come to that. Therefore, when I said that I had to understand what IRI and PUSA stands for, so I thought some new definition for IRI and PUSA. And I thought that IRI can best be described as the iconic architect of revolutionary innovation, and PUSA stands for in publicly useful solutions for agriculture. I think if we combine both of them, that's what I thought IRI and PUSA stands for. And it really came from my heart when I talk of IRI. Although I was in, as Professor Sapori said, I was in CSIR system. But I think I was never disconnected. I think my umbilical cord was always attached with ICR in some way or the other, and that you will see in my journey also, whatever work which I did. And when we talk of IRI, I remember in this hall, although Dr. Swaminathan Saab was not there at that time, DG ICR, but he had come from Philippines and he had delivered a lecture here on food security at that time. I think for students like us, we hardly understood what the food security means. We never had any understanding of the word food security. But sitting on the staircases of this hall, we used to listen to his lectures, try to understand what he wants to say. And when he received Bharat Ratna, and our Honorable Prime Minister said that apart from transforming Indian agriculture, he ensured nation's security and prosperity. So I think that was the basic theme I picked up from here, that when I had to deliver the Foundation Day lecture, it should be tribute to Bharat Ratna Professor Swaminathan Saab, and this word prosperity is very important. And prosperity, it comes from economy. So I thought, let's try to understand what this economy is all about and how we can generate using biological resources. Very recently, if you see in DBT, particularly on the BIREX site, there is a Indian Bioeconomy 2023 report. And that report very clearly says that today's India economy is around $134.24 billion US, which is approximately 4% of the nation's GDP, which is crossing $300 trillion. I think it's a huge contribution of Indian bioeconomy to the total nation's GDP. I think once you get that sort of figure, and when you see that our aim is to make it a $300 billion economy by 2030, particularly in bioeconomy, I think institutes like us and the scientists like us have a lot of challenges. And I think we have to meet those challenges. And to meet those challenges, I think it's important if you understand what are the various components of Indian bioeconomy that we talk about. And very interesting, when I saw about this Indian bioeconomy component, one of the things was written there as bioagri. So even in agri, they are using the word bio before agri. I fail to understand though why they are using the word bioagri, but at least they probably want to say that bioeconomy through agriculture is very important. And it was so happy to see that even things like BT cotton and biopesticide, they constituted about 11.5 billion US dollars worth bioeconomy per annum. I think it's a huge sum what we are doing. And just now we heard the report from Dr. Singh that how IRI is contributing for rice, maize, etc. And the second thing, if you see the bio-industrial component where you have the things like biofuels, bioplastic, etc., its contribution is almost like 59 billion US dollar per annum. And I think it's a huge contribution and huge opportunity exists in this area. And we can really take India to the next level if we combine bioagri as well as bioindustrial. And to contribute in that bioindustrial, where you have things like bioplastic, biofuels, microbial technologies, rDNA technologies, enzymatic application, I think our institutes can play very, very significant role. And similarly, we have other sectors like biopharma, bioresearch, and biotech, and other IT sector, where bioeconomy, which are basically the service area, where we can all contribute. And just to give you few examples, like, if you see some of the major companies today which are in the area of bioeconomy, like Serum Institute of India, it's a 3.2 billion US dollar revenue generating company. I think it's a very huge amount that this company is generating. Maybe COVID must have contributed significantly, but that is the scenario. Similarly, if you see Biocon in the area of agri-biotechnology, seed companies, in bioindustry you can see enzyme companies, they are coming up very, very well, and they are contributing so significantly. Now, the question is, if this is the current scenario, what and where we can move and what can we contribute? And I come to that now. If you see the challenges in this bioeconomy area, there are few challenges out there. And most important thing is, do we identify the right question? Do we identify that what we are trying to solve, what we are trying to give to the nation? That is the prime. And most of the time, I think that's one area where we make some mistake and then we end up into the trouble. So I think identifying the right question is very important. And when we talk of bioeconomy, so quality and quantity of biomass, it assumes very significant and very important position. And here, if you have to improve the quality of biomass, certainly breeding assumes central importance. Your biotechnology assumes central importance. So innovative breeding does not only involve the classical breeding, but it involves all sort of breeding and also other disciplines like plant physiology, chemistry, they also come and play a role when we talk of innovative breeding. And in economy, when we talk of economy generation, industry plays a significant role, not only biological things. And to make the things industry compatible, we need to have the proper processing technologies, we should have value addition, and we should have skill development, and very important, market linkage. And for market linkages, our packaging and branding, these are very important components. So when we talk of bioeconomy, I think the scope is very high. And then there are challenges of climate change, then there are challenges of degrading soils, all those challenges are also there. So we need to be very, very thorough and very, very cautious how we move ahead into the area of bioeconomy. Now I'll give you a few examples that I have been doing. And one such example I'll give you, and this we consider is very important example, because in this case we started right from discovering something and we took it to the industry. And we did almost every component of this particular enzyme. We were working at high altitude, and that height was around 15,000 feet in Lahaul and Spiti. This place is known as Kunzam Pass. You cross Rohtang Pass and then you come to Kunzam Pass at 15,000 feet. And Normally it's a desert area and suddenly you see a plant, a whole area is green and you see this plant and then you ask a question, how this plant is surviving there? And this very lush green plant. And as a physiologist, one thing comes to your mind that under such an environment of high radiation, low temperature, fluctuating temperature, immediate thing could be that its defense system should be very, very strong. And we had some idea from Professor Sapori's lab, like SOD and APX, all the enzymes are involved in this pathway. So we started working on this enzyme, particularly the antioxidant defense pathway. So superoxide dismutase, ascorbic peroxide, catalase, all sorts of enzyme, complete thing we started working. And when we studied the very first enzyme known as superoxide dismutase, which converts the superoxide radical, the first thing which is produced under stress condition and converts it into hydrogen peroxide and water, what we realized that this enzyme can be autoclaved, number one. And secondly, this enzyme can be functional even at sub-zero temperature, which was very, very unusual. So you add some glycerin, you don't allow things to freeze, and this enzyme will be functional, even at sub-zero temperature. And that was something very significant. So we worked out this complete structure, and we found that it is one of the most compact enzymes. Then we created several mutations of this enzyme, that whether there is some interesting changes take place or not. And what we realized that it's a 152 amino acid long enzyme. You cut even 2 base from any side, enzyme suddenly loses activity. That was very interesting. But what happens is, this enzyme exists as a dimer. And at the dimer you have a cysteine moiety. If you mutate that cysteine moiety, enzyme becomes monomer, that we showed in the left hand side of this slide. It becomes a monomer. And after becoming monomer, it becomes more conformation. Its conformation becomes more stable, number one. And secondly, kinetic parameters are improved. So it becomes even more thermostable. So you can autoclave now this enzyme 3 times and nothing happens to this enzyme. So it is stable at room temperature. So we thought it's a very class thing if you have to transfer it to the industry. So we discussed with the industry partner. They liked it. So now our next challenge was that we had to do upscale production of this enzyme. And we had to bring it to crystallization stage that anybody can dry up this enzyme. So we went up to at least pilot scale up to 150 liter. At Imtech we tried at 3000 liter bioreactor. It was all functional. We all standardized everything. And once we achieved this upscale production, and the production of enzyme, you can see, you can make approximately 350 milligram per liter. That high quantity of enzyme production. And I think it's a class example where you can produce such an enzyme at such a high quantity, 350 gram per liter. So the company becomes very happy because the cost of production becomes very low. They can produce as much enzyme as they like. So if you go to this phytobiotech site, they write that it's the enzyme. I think in the world you get the most purified enzyme and most unique enzyme. I think it's lovely to see their site, how do they advertise. And if you see this enzyme book, you will find that this enzyme is listed, phytobiotech is listed as one of the enzymes which can be, this is one of the major global player in the world for this SOD enzyme. So this was something very interesting from our point of view, that as a physiologist, we discovered something and then took it to the industry. And still today it's working. Now, second story I wanted to share. So this was how you can, if you see today's topic, that from bioeconomy point of view, how enzyme can play a very significant role in industrial development. And that's how we gave enzyme to one industry, but that industry is giving enzyme to so many other companies. So many other industries are working. So it's one example of bioeconomy generation through our classical research. Now, when we were working again at high altitude, their partial pressure of gas is very low, about 30% lower at that place compared to what you have in Delhi. And when you walk, you feel that there is very less of oxygen. So we wondered how plant adapts at low carbon dioxide concentration. I think that was one of our second question. So we did that classical experiment of 14 CO2 feeding. We did classical experiment of all enzymatic analysis. And then we came out with a new mechanism where in plant both C3 and C4 apparently looking pathway are working together. And why they are working together? Because what these plants at high altitude are doing, that whatever carbon and nitrogen which is emitted during photorespiratory process, they are being reabsorbed. So it was a new concept altogether. We don't have to convert C3 plant into C4 plant to make it more efficient. But if we can refix the carbon and nitrogen which is emitted during photorespiratory process, the plant become more efficient. So once we came out with this hypothesis, we said let's try to transfer this into some other system. So we put it in Arabidopsis initially, and now we have put it in Brassica, and it was very interesting to see. This plant, they can reassimilate photorespiratory ammonia. We showed it very clearly. Also, this plant can reassimilate the CO2. So there were very less photorespiratory CO2 evolution. These two data were very, very evident. And then we saw that all the metabolites are transferred in towards amino acid biosynthesis. So the health of a plant, what we have shown here in this panel, you can see all the transgenics were very, very healthy. I think now I wanted to share with you, while we are trying to convert C3 plant into C4 plant, these plants can function at lower level of nitrogen. For example, if your normal plant needs 100 kg nitrogen, such plant needs only 70 kg nitrogen. That we had shown, at least under lab condition, limited trial condition, because we can't go to the field as per the current laws. So this was very beneficial. Now we have tested in Brassica, and Brassica this pathway works very, very well. And I think so we are now future ready if you have to transplant such mechanism into wheat or any other plant, and when government permits, I think we are ready with the mechanism, our cassettes are ready, and we can transplant this pathway in any plant that we look for, and plant can function at lower concentration of nitrogen, and it can give you the equivalent yield or even better yield if you give them the equal level of nitrogen or 100 kg of nitrogen, whatever is the standardized one. So this was something very useful, and it was also recommended, after our publication. There is a F1000 prime group, which also is nowadays it is known as faculty opinion. It picked up our paper, and they said that for nitrogen use efficiency, this is a class example, and we can go ahead with this. So they, third party also realized the importance of this work for converting C3 plant into C4 plant to reduce the photorespiratory losses. So, and then this work came into several books, and I think not only books, but even if you see any review article, everybody covers all our high altitude work very, very well. I gave you here only one example, but like this we have series of such examples. I am not giving you all those data, otherwise it will take a lot of time. So then we try to put this mechanism into, so these two, after these two mechanisms which I just shared, one point I also wanted to share that we have now series of enzymes in our lab. We have series of such genes in our lab which we evaluated in several crop plants. And now we have the events ready. For example, if we have to improve the lignification of vascular system, we know which gene like SOD and APX we have to use. If we have to improve the shoot regeneration, then we know which gene we have to use. And like this, we have now whole series of sets of genes. For example, for charcoal rot in potato or late blight tolerance in potato, we are having now the genes with us that we have already evaluated and tested. Similarly, if we have to grow the plant under fluctuating environment, now we have the mechanism. For example, what sort of chaperones are needed, what sort of photosynthetic mechanism are needed. So all these mechanisms are now there with us in our lab, which is ready for our future and next generation agriculture, in our opinion, and which we can always use. Apart from that, if we had to go towards medicinal or metabolite production in the plant, at least in 5 different plant species, like for example tea, mycorrhiza, stevia, arnabia, we have the complete pathway ready. And using the genes of tea, we put it in tobacco and we succeeded in making catechins in tobacco. So we have now the system available with us where we can produce the desired metabolite in alternative system. Similarly, we have now the transcription factors. Suppose we have to modulate the fucoside contents which are used for liver treatment. We have the transcription factor and one can always change that. So just a summary slide I wanted to share with you that even in the secondary metabolite modulation, we have all the know-how ready and one can modulate it. Only thing is that we need to have government permission. Now recently SDN1 and SDN2 permission has already been granted for genome edited crops. And I'm sure that as the demands comes, hopefully if this permission comes, then we have the genes and the processes ready with us. Now I wanted to shift little bit more towards the industrial aspects. For example, bioplastic, in the whole world, you have approximately 390 million ton production of plastics. And in agriculture area also, we use lot of plastic. And you are all aware how much plastic is there into the agriculture. So we were working on prospecting in microbes for bioplastic production. And one of the major challenges is cost of production of bioplastic. So the easiest way is, since it is all microbe based, it is bioreactor based, so you have to identify such bacteria which produces some such metabolite which yield you higher prices, so that your cost of plastic production is automatically reduced. For example, in this bacteria makes a pigment known as violacin, which is a very expensive molecule which is used in cancer treatment and some other things. But at the same time, then bioplastic becomes a byproduct here. So if we consider such things, then it is so useful. So once we discussed with the company was very interested. Now the company is incubated and they are producing the PHP in the lab, and they are selling the violacin, and PHP becomes their almost sort of a byproduct, right? So this is yet another example that how one can create economy using the biological resources, right? So this is a bioplastic economy. I thought I'll just share with you. Now we are sitting in this hall, which is known as BP Paul Hall. And if you talk of BP Paul and floriculture, particularly rose, I think they are almost synonymous. So I thought when it comes to the application side, let me start with some floriculture mission, particularly for this hall. And what we focused in our institute back was that we thought, let us focus on those crops on which India is dependent on external countries. For example, tulip. Every year we spend crores of rupees to get the corms from Netherlands. Similar is the scenario of lilium. Dr. Markanday is sitting in the hall. I think when he was at IHBT, he had initiated this work on lilium and Lahore and Spiti, right, Dr. Markanday? And then Kela lily. So we started some of such crops for which India was dependent on foreign countries. And what we did at IHBT, that we developed the production technologies for bulb. And once we developed this production technology, we thought, particularly for tulip, I'm just giving you here example, this production technology was transferred to the farmers and all the farmers adopted it. Now farmers are become very proficient, and you can see the first tulip garden at Himachal Pradesh, it was established by us, using the bulbs which are producing indigenously. So that was one of our major achievement, and Palampur is today the tulip city. You can Google it and you will know it that when it is there. And very recently, during inauguration of our Ram temple, the tulips were sent from Palampur, and it was acknowledged by one and all, including our Honorable Minister, that during this off-season, a tulip came from Palampur. and we had developed this technology. And here, you know, things like our hydroponics, it had helped us a lot. Actually, we had standardized the hydroponic technology for production of this high-cost bulb, and even off-season, we can do the production. And this technology was transferred to at least 3 different partners, and they are all making this high-valued medicinal plant production in places like Punjab, Andhra. All high-altitude medicinal plants are produced under this hydroponic facility and aeroponic facility. So that's how we made some of these changes in the agriculture classical pattern, and it made the whole changes in the livelihood scenario. Another thing, you know, we had mastered the lilium production technology, and we thought, why don't we take it to the area where there is complete lacking? So we focused on place like Ladakh and Leh, where environment is very conducive, but there was no floriculture activity. So we put this lilium production in Leh, and very interesting what you see here. For the first time, lilium production took place in Leh. First shop on floriculture opened there, and not only first shop was open, but they started sending the lilium to Delhi from the first flight. So suddenly now there is the entrepreneurship development. There is one unit which is just busy in producing the bulb, others are producing the floriculture, and that's how it changed the whole scenario. And it is just you know, showing that how many people started attaching with us, and it really went pretty high. But one thing I thought I'll share with the youngsters here, that MSME comes very handy if you have to make some such entrepreneurship activity in remote places. Because for floriculture, what you need a packaging center, you need storage, you need transportation, and from where the money will come. So we approached MSME. MSME said that if you make the cluster, it will be possible. So we established 2 cultures there in high altitude regions, and both clusters are now fully equipped with all the gadgets. So they do sorting, they do packaging, they do transportation, right? And that is how we converted the classical agriculture into agri-entrepreneurship. And this is just, and what we did, we developed the production technology here. Another thing I wanted to share, because we all talk of Atmanirbhar Bharat. And as Professor Singh said, that we are self-sufficient in grain production. But there are certain areas which still need attention. Floriculture I just mentioned. And aroma crops, like, you know, flowers, like for example, roses. Dr. B.B. Pal, he had love for roses. But when you talk of rose oil, still we import in this country about 40 tons of rose oil. If you talk of Tagetes minuta or marigold, we import around 12 tons of oil in this country. Why? When we have all the environment, we have the process technology, everything is there. So why we thought that let us try to identify those oils on which India is dependent on external world. And we should now do it in a mission mode, that in 2 years or 3 years time, we make India total net exporter rather than importer. So with that mission, we started some of the activities, and Professor Sapori, he is chairing our that mission on aroma also, where he is regularly monitoring what we had done and what actually still, I think, sir, in this phase also you are chairing that session. And I must share with you that we had done, it had the different components in this mission. For example, varietal development. Second was on nursery development. Then we had to establish the distillation unit, extraction unit, quality assessment, storage. So we had taken all the components which were needed right from cultivation of farmer field to the industrial outlay. So we did all the things, and you know the interesting thing what had happened? After that, when we were importing 12 tons of marigold oil from Africa, now 8 ton was produced just in Himachal Pradesh alone. And from the land from where people were not getting even a single rupee, from that land people were generating more than 1.5 lakh rupees per hectare. So that added a lot of value to the farmer in terms of their economy. But at the background, we did all the breeding work so that we had the right variety. We did all the processing technology so that we knew that how it has to be extracted. And also we developed all the processing unit which could be taken to the farmer's field. So that's what we had done, and that's the result that we got. And not to give you the values, but just to show you that it attracted the attention of a lot of farmers, and we went ahead into this. Professor Sapori was mentioning about apple production in Northeast. Actually, we had visited Northeast, and what we realized that they get all the apples either from Myanmar or from Kashmir, but by that time it reaches Kashmir, it was almost, not in a very good shape. We thought, why don't we empower the farmers there and let them also start cultivating apples? But for apples you needed the right root stock, you needed the right type of varieties. So what we had done is, we had empowered at least 5 different tissue culture companies with the root stock technology production, and also with this grafting technology, with the right varieties. Anna and Dorsa we had initially started, and today you can see there are more than 3 lakh of root stock, and all are planted now in Northeast. All of them are getting good money, and in the process, ultimately, when it reached to Honorable PM's house, he also mentioned in his Man Ki Baat that how people in Northeast are now started cultivating apples, and I think that was again a very significant move from lab to land, and in terms of entrepreneurship development of our tissue culture units in between. An interesting thing I wanted to touch upon. Tree felling is a very big problem for house construction, for our chair construction, everything. And just to give you some idea that in 2021, more than 30 lakhs trees were felled. And trees take approximately 20 years before you could harvest them. We thought, why don't we take an alternative strategy? In India, bamboo you can harvest, and in 6 to 7 years time, bamboo is ready. But to make bamboo ready for at a stage that you can make chairs, you can make tables, you can make furniture or household, you need to have your technology for making the composites of that bamboo. So what we did, we had the tissue culture technology with us, we had the agriculture technology with us, agro technology with us. So we shook hands with one of our sister labs who had expertise in making the composite. So now we ensured the quality of biomass, and that lab ensured the quality of composite, and as a result of which we succeeded in making the bamboo composite, and you can see now various structures were being made out of bamboo composite, including chairs, tables, tiles, and also house. They were all made of bamboo. So bamboo is just as an example that you can use a raw material which is reusable, which can be easily cultivated, for which you don't have to spray much, no fertilizer is needed, and you can see you can convert into a very useful industrial product. So just to show you that some such things can also be thought of in terms of empowering our industry. Few things I wanted to mention, and I thought that being in agriculture institution, it's important that some of the things, some of the leads that we took, sometimes we take it for granted, in our everyday food we eat hing, and we take it for granted that it is produced in India. When we were focusing on the data, that what are the things on which India is dependent on import, we realized that hing is one such issue. And all the hing in this country comes from Afghanistan, Iran, around 1500 tons, and it is not a small quantity. we thought, why can't we produce this hing in India? So we tried to talk to the people. Some people said that hing comes from some rock. Somebody said it comes from some animal. And we, as a student of botany, we understood that it is a ferula species which gives you the hing. And our botanist told us that Ferula asafoetida does not exist in India. It exists in other part of the world. And probably at one time Afghanistan was part of India, so we never bothered after separation that we should have been at least taking the hing into our control. So hing plantation was totally in Afghanistan. So with a lot of difficulty, after writing around 8,500 letters, we got 100 gram of seeds in this country, and here ICR played a very significant and positive role. I think with the help of NBPGR, they ensured that we get the proper permits, and they really facilitated, and as a result of which, and they showed us that, in the last 30 years, there was not even a single hing seed came into this country. So they gave us the record. So we brought in hing seeds, and the germination rate was 1%. So you can well imagine, so we now made the germination rate to 87%. We developed proper agro technologies, nurseries technologies. We shook hands with the state government. Now state government ordered that we should be planting hing in different parts. So using the state government machinery now, hing plantation took place. So all Lahore Spiti, Ladakh and Uttarakhand, we spread the hing. But I think if we work very closely with ICR in terms of hing cultivation, at least in hing Atmanirbharta, we will be able to achieve very quickly. And we have the tissue culture technology in between, so that tomorrow if you don't have the hing seeds, at least we have the tissue culture for plantation. So we developed in between all that. And complete chemistry was developed, processing technology was developed, because ultimately we have to take it to the industry. So processing technology is also very important. So hing is now, we feel that in 2025 we should get the first extract of hing in this country, the first indigenous hing. That's what we are expecting. Another thing Professor Sapori mentioned about this monk fruit. This fruit, it gives a molecule known as mongrosite, which is 300 times sweeter than sugar, and it does not add to any weight. It's safe for diabetics, and also it does not have any aftertaste. Surprisingly, all monk fruit cultivation takes place only in China, processed in USA, and from there it is distributed throughout the world. So we decided to get these seeds again in India. And again, NBPGR came to our rescue. We took proper permission, they gave us proper permit, and today this monk fruit is being cultivated. So we developed complete biology of this plant. Already one paper has been published on that. Then we developed tissue culture. The second paper came only this year. So now we have male and female plant tissue culture technology. We put it into the farmer's field. We evaluated that which is the best area for hing cultivation, and now hing cultivation started taking place in Himachal Pradesh. So again, from conceptualization to lab to the land, we succeeded in this monk fruit. And it's a 3 months crop, so it's not a very big deal. Similarly, saffron cultivation. At one time it was supposed that, beyond Pampo region, where it is around in 3,000 hectares, we are cultivating this saffron. And about 9 tons of saffron we produce in this country. Our demand is 100 tons, from where the 90 tons compensates. So it's certainly coming from Iran, from other countries. So we said, why can't we take saffron out of Kashmir? So now it is in Himachal Pradesh, in Uttarakhand. So we developed again tissue culture technology for bulk production, agro technology for taking to various places. And in all these experiments, we take a lot of help from ecological niche modeling, so that we identify the right locations. So we do all this at the background, and today you can see saffron production coming in various parts of Himachal Pradesh and Uttarakhand. Similarly, dalchini, we thought that it's a Kerala product, and we assumed, because center of origin is Kerala, so we assumed that India produces a lot of dalchini. But when we saw the data, when we talked the ICR institution at Calicut, so the director told that we hardly had 2,000 hectares under cultivation, and all the cinnamon comes again from outside the country. More than 45,000 tons come from outside the country. I said, why can't we have the cinnamon in this country? And then we started, we signed MOU with that Calicut Institute, but we had to do a lot of indigenization so that we could take it to the farmers in Himachal Pradesh. And today you can see it's the third year in Himachal and it's going very well. I think again next 2 years we will have the first bark of cinnamon. And like cinnamon, we did licorice or mulati, during this period of COVID, everybody learned about mulati. All mulati comes from Afghanistan, we were surprised. In Hisar, there was some attempt. So what we did is, we thought let's start licorice cultivation in Himachal Pradesh. Again, we developed the agro-technology, tissue culture technology, and put it to the farmers' field. So this was some of the things we did in terms of introduction. Now for industrial development, there are 2-3 things are also important. That we had to develop certain products. And I remember in 1995, there was a moment, and we call it as, oh wait, that was ours moment. What was that? Dr. Mashelkar, he took over as the Director General of CSIR. And one day he told us that turmeric is our thing, and in USA there are 2 guys, Das and Kohli, they took a patent on turmeric for healing purposes. And he said, it's not acceptable, that's our thing. And that's what happens in our country at times. Something which is ours, we don't realize the importance. When others do it, then we realize. And I think that was the result of that patent, although India fought that patent, and after 3 years, India took back and the patent was retracted. Intellectual property was ours. But in the process, what happened is, a unit known as Traditional Knowledge Digital Library was established, where all the traditional knowledge of our nation was stored. And today we have around 4.5 lakh entries in that library. And in 2022, now this library is open to all of us. So any of person sitting in this hall wants to understand X plant is used for what purpose, they can approach that library and they can understand it and they can make formulation, right? And being inspired by that, in 2022, now WHO and Government of India have signed an agreement to establish a WHO Global Center on Traditional Knowledge and Traditional Medicine. Why I am discussing here is that in ICR, we work, also we have an institute on traditional knowledge, on traditional plants, medicinal plant, aromatic plant. We have that institution. Now, if we can ensure that that institute is also linked to some product formulation or linked to Ayush Ministry or the relevant agencies, I think new product formulation, new product things, I think we can empower our country even on traditional knowledge base. And I here give you an example. Whenever we undertake such activity, we always discuss with the industry that what is needed in next few years to come. For example, here we had a meeting with the industry, and industry said that malnutrition is a major problem, whether it is a vitamin B12, vitamin D2, zinc or iron. They said if you can develop certain products around that, that would be significant. Then they said bone health is very important. I think everybody's cartilage is almost destroyed. So if some product can be developed around that, that would be significant. And that's how we prioritize that where we should work upon. And here I am giving you an example. Using this list, then we search the literature, and for bone health, they suggested a few plant species which will be so important. So we took those plant species, we standardized the product, we worked out the mechanism, and we developed the product, and after development, we did its human intervention studies, that whatever is written is really right or not. So with the medical college, we did the human intervention studies, and once it was finalized, then the product was transferred to the industry in 2022, last year only, and I think next year onwards they will start the production now. So all those things probably we need to do whenever we have to reach to the market, particularly for bioeconomy, because here industry becomes very important. And to reach the industry, it's important that we do the proper human trial. Another example I'll give you. Recently I saw this report of IIHR also. They also came up with a mushroom with high vitamin D content. Very recently I saw that news item. Actually, 4-5 years back, we have developed this shiitake mushroom technology for high vitamin D content. And we developed a range of products. And we also did proper allergenicity assays that if it is allergic, then it is allergic to what matters. So we have a proper allergy report. And also we have the proper human intervention studies through a medical college. So we have those studies as well. And now, once we were ready with all this data, you can see 9 different companies have taken this technology. All of them are producing it and sending outside the world because it has a lot of demand outside the world. And also MSME supported this activity. 3 clusters are established, not only in Himachal Pradesh, but also outside the Himachal Pradesh. And a lot of entrepreneurship has been generated using MSME. And coupled to that, we did some microalgae based experiment. Again, we developed the product, evaluated, did in preclinical trials, and once it was done, all the products were developed. And once the products were developed, now it was integrated with Poshan Abhiyan, or the food supplementation program of Government of India, and all these products are part of now that program. People don't like that classical things, but they like our things because it's very delicious. It suits to their taste. It's made for lactating women. It is made for young girls. So that, anemia problem, zinc deficiency, these 2 things are taken care of, and also vitamin D. So these for 3 things, now we have all these products ready. So these are some of the things I thought I must share with this hall on this very important day. And almost my last but one slide, that with all these technologies now, we have a lot of startups. We have around 56 startups came up. And let me give you a theme around that startup. If you say any startup that you come and make your startup, nobody comes like that. We thought when we give a student some monthly remuneration, why also not to startup, we should start giving something. So we had discussion with our CM, and I think there was a CM startup scheme. Under that, they would give to each person some monthly emolument, around 20,000 rupees, and to the lab also they would give us some money. So the person who want to make a startup, he would be in our lab, develop the product and take it to the market. Because there was a condition, if you don't make your startup, you will have to return all the money. So because of that scheme, the advantage was that a lot of a startup came up, lot of their product came up, and I think this was something, a very positive activity from our institute which took place. And just to tell you that, since we had a lot of product developed, so around 88 different entrepreneurs, they were connected with us, and we had transferred them whole range of technologies. And all their products are in the market. They are not just to display it, but most of the products are in the market, and through Amazon or some platform they are available. Now, this was something I wanted to share, that how individual institution can contribute towards economic generation. Now, in times to come, what are our future projections? And this I again took from that BIRAC document. And most important thing that will focus, and which Dr. Singh also mentioned, about this biofuel is going to be the major thing in times to come as far as bioeconomy is concerned. So any activity towards biofuel is going to add a lot of value. Bioservices, whether it is a IT-based services or any such services, that is again going to play very significant role. So these are two major top players which are going to be the next bioeconomy thing. Apart from that, even things like poultry field, even things like medical diagnostic, vaccine, they are going to play a significant role. But as far as ABLES or BIREX projection are concerned, these are the major things. But I feel things like bioplastic, if some of the people, they are coming and they are going to contribute, that might contribute very significantly in times to come as far as bioeconomy is concerned. And if you see the government policies, I think it's totally enabled towards bioeconomy generation. Whether it was a permission to add ethanol to the fuel, whether it is a question of permitting some SG1 or STN2 events in the our genome editing or things of that size, right? So government is also facilitating some of these things, and I thought it's important that audience should know that India is going towards generating economy using biological resources, and biological resources have enormous power. An institution like ours, they can contribute so significantly in various areas, but important thing is that to that biomass we do some value addition, we do branding. I think it will lead many things. And I acknowledge all my former institution, even our EMPRI and various funding agencies, they really had helped us a lot, and all our students and staff. And in the last, I must thank you with this old photograph of our plant physiology. I don't know how many of you can identify. Professor Sinha is sitting here. He was earlier the director at ISBT. Dr. Asana is sitting here. Dr. Surohi is sitting here. And Dr. Deshmukh Saab is also here, who is sitting in this hall, right? That's how you could recognize yourself, right? Madam Renu Khanna Chopra is sitting here. So this is one of our old classical photograph I pulled out because today if we are somewhere, I think this group had played a very, very significant role in making our lives what we are today. So thank you very much for your all patience listening. And thank you, Doctor, for giving this opportunity that we could share some of our work. Not otherwise, sharing all would take time, but just wanted to share that how economy could be generated using biological resources. Thank you so much. Thank you.
Thank you so much, sir, for sharing such valuable insights about bioeconomy. It was truly exceptional, informating, engaging, and delivered with great expertise. Let's have a big round of applause again. Now I would like to request Dr. Sudhir Kumar Sapori, sir, for his kind remarks. Sir, please.
Friends, you would agree that we just heard a very, very good illustrative lecture from none other than Dr. Sanjay. His presentation was very clear. He wanted to tell you the scope of bioeconomy in this country. And also he mentioned and he proved that if you think through the problem carefully, plan it well, and your objectives are clear, that where you want to reach, then accordingly you will give your inputs into the basic and fundamental research, and the knowledge driven through that research work, how that can be taken further to bring into a product development. That's what the whole bioeconomy is talking about. Biodiversity to start with, that is the key point. Biodiversity is becoming a major area of investigation. And maybe some of you might have known, Dr. Sanjay, what they call now is a new omics, and that is imageomics coming up. And they want to image the whole biodiversity under different sensor systems, compile this whole data at one place, and then use AI technologies to tell you how this biodiversity will be able to survive or grow in future based on the climate changes which are coming up. So totally a new branch of this biodiversity is coming. So basically what we are saying that we have so much of plant material available here which can be used to develop bioproducts, bioprocessing technologies can be done, and converting that into bioeconomy. That will feed into the bioeconomy of this country. The other component of his lecture, I take it from the point of view of Government of India's policy to make this country Atmanirbhar. Why do we depend upon hing from Afghanistan or from other products from different countries? Of course, during evolution, plants have adapted at different places and they are grown there. The technologies are breeding technologies, other things have been used over the many years in order to change those adaptations at different places. But it is also possible through knowledge generation, agro-technologies and others. You can get the plant from outside, grow it here. Maybe it gives you better product in your own environmental conditions. And this is what his research work and their institute have demonstrated, that you don't need to depend upon products to be imported in this country, but at the same time grow it on your own places. Not only getting it from outside, but very interestingly, as a botanist, I look at that you can change the adaptation of apple plant. For example, it is always fascinated where we thought it is growing only in Himachal or Kashmir. मेरे कश्मीर से तो सब कुछ उठा के ले आ रहे हैं आप, क्रोकस भी ले आए, एप्पल भी ले आए, तो मैं वहाँ क्या रह गया हमारे लिए. So we used to say Kashmir Valley is a crocus valley, so but now we cannot even claim that one. So this is the power of science. Then you can change the adaptation of plants from one place to other, and even make it better. They grow it better and give you better produce and so on and so forth. So I think this was a very excellent talk. Importance, your initial days is to the breeding programs, but we started giving later on all the new people who came, they wanted to get into more genomics-based approaches, which is also important at the moment. I remember when I was working at Max Planck Institute in plant breeding in Cologne, and there are a lot of basic fundamental work which was going on. But the most respected scientist in that institute was the wheat breeder throughout the Europe. He was the one whose variety was being cultivated all around. So not that he was the one who was most respected, this person was the most richest person. So he not only developed the economy of the Europe through this variety, but he was also getting some kind of a money for developing this variety. यहाँ पे policy नहीं है. Does breeder get any money out of the sale of that variety? So that is not there. That incentive is probably lost somewhere. But I think this institute is what I sometimes feel the IRI is one of those institutes which is tried earlier and even tried to meet the United Nations goals on alleviating hunger on this planet. There are many institutes, the CGR institutes and others who are working in this direction. But amongst many of those institutes at the international level, IRI's contribution and also a related institution. But IR, I think, is one of the main ones whose contribution is enormous in this country. And I think this has to be acknowledged. is being acknowledged by developing different kinds of varieties which they have done over the years. Sometimes you feel that I was not an alumnus of IRI, but I had a good association with IRI right from the days of my PhD. And I was doing PhD in Delhi University on plant tissue culture, on developing haploid plants. And Dr. Swaminathan was one who was pushing this technology at that time. And he once told that although the discoverer of this technology, Professor Maheshwari, with whom I was working, he said, although he has developed this, but he has not realized the potential of this. And that was the issue. He said, this technology has enormous potential, and a place like IRI is the one where this potential can be realized. And that's where Shipra Mukherjee was taken up in this institute to develop haploid technology for rice, because it was developed for Datura plant in Delhi University, but they started all working in the rice. And this technology flew to China, and where all this work was done later on. So I was working in the same applied production, but there were some issues in Delhi University. I don't want to get into this. So Professor Maheshwari said that if you want to get some help, you should go to IRI. And Dr. Raina those days had started some work on haploid plant production. So I used to come here for all my photographic work, some kind of tissue culture work. RI was a great support to me in order for that I could complete my PhD degree. I used to visit IRI. It was, you would always remain in awe when you meet people or the scientists of this institution. Professor Maheshwari used to bring me to IRI to meet different people. He said, बड़े लोगों से मिलोगे तो बड़े ideas आएंगे. So that was one of his thing, always in the mind. You must, first thing he was to tell, you must attend all seminars. And when you go to the seminar, you must carry your notebook with you. Take notes. I still do that. Even in ICB, when I go or anywhere else, I carry a notebook or some pages to put down. But I don't think many people take notes of any of the seminars. अब भूल जाएंगे जो संजय जी ने आज यहाँ सारा बताया. By the time you reach home, you will forget about it. But these notes somewhere help you later on when you flip through the pages, ki what I heard and what I can use this knowledge in my own research work. I think that becomes very important from these lectures. So, but Professor Maheshwari used to say, attend lectures and meet people who matter or who have contributed. So my first introduction here was with Dr. Swaminathan. Dr. Swaminathan was my PhD examiner. And when I heard about it, Professor Maheshwari said, Swaminathan aa rahe hain, preparation thi kar lena. So, that was something you remember the way he examined you, the kind of questions. It was very mild, but questions were penetrating, and which made you think that maybe you could have done this way or the other way, maybe a better way to finish your work. Then I met Dr. Jain and many other people in genetics, in plant physiology, Dr. Sinha and all that. And this morning when I came, I was a little early, not little, 1 hour early, and Dr. Singh was sitting and working on his table. I entered his room. तो मैंने कहा अपना काम करिए, मैं चुप करके बैठता हूँ, because luckily there was no traffic. I had to come from Faridabad, so I reached early. Now when you look at the pictures on the wall in director's room, and that gives you an idea the kind of leadership which this institution has got, not only at the level of directors, but at the level of heads of departments and so forth. Right from Dr. P.P. Pal, after Swaminathan and many other directors, it reminded me back that I met all of them. Maybe उन्हीं का कुछ असर था कि कुछ थोड़ा बहुत काम हम कर पाए by meeting all these great people. So it has been your journey, your ideas are driven by association with different people, by listening to different speakers, by reading, interacting, and I think that becomes very, very important in one's lifetime. So IRI is one can go on the kind of contributions it has made. We are really proud that such an institution exists in this country. And Indian agriculture overall, not IRI, also has actually played a pivotal role in combating food insecurity, which I was just mentioning. I think it's a time to pat your own self now that what you have done. And my congratulations to all the scientists, to the staff, the leadership which has come. Also to the Government of India that they have been supporting agriculture system in this country in many different ways. That today, as he was mentioning, we are living in surplus state. I think you are able to feed 80 crore people, you give free food. We couldn't have imagined when we were growing up in 50s and 60s and you had to stand up in line to get 2 kgs of rice, rationing was there. And today you are supplying free food and exporting food is a miracle, nothing less than a miracle which has happened in a country where you have to feed 140 crore लोगों का सुबह का और शाम का खाना आपको provide करना है. This is contribution of institutions like IRI and many other ISR institutions. It's my privilege that I had to be here today along in this foundation day of this great institutions. Thank you very much and wish you all the best, all of you.
बहुत बहुत धन्यवाद सर. आपकी उपस्थिति, गरिमामय उपस्थिति से हमारे अंदर ऊर्जा का संचार हुआ है. आप हमारे साथ जुड़े, आपका बहुत बहुत धन्यवाद. जगमग नगरों से दूर दूर जहां न खड़े ऊंचे महल, कुछ टूटे फूटे कच्चे घर, दिखते खेतों में चलते हल, पुरई पाल खपरेलों में, रहीमा रमुआ की नाव में, है अपना हिंदुस्तान कहाँ, वो बसा हमारे गाँव में. और उन्हीं गाँव में रहते हैं हमारे किसान और उन किसानों तक पहुंचते हैं हम कृषि प्रसार के माध्यम से. और कृषि प्रसार के लिए सबसे उत्तम माध्यम होता है हमारे वैज्ञानिक प्रकाशन. मैं हमारे कार्यक्रम के अध्यक्ष डॉक्टर सुधीर जी, डॉक्टर संजय कुमार जी, निदेशक महोदय एवं संयुक्त निदेशक प्रसार डॉक्टर पडारिया जी से अनुरोध करूंगा कि संस्थान के प्रमुख प्रकाशनों को विमोचित करें. सबसे पहली कड़ी में शामिल हैं हमारे स्तंभ शिक्षा के द ग्रेजुएट स्कूल के संयुक्त निदेशक शिक्षा एवं अधिष्ठाता डॉक्टर अनुपमा सिंह जी के गाइडेंस में तैयार हुए हमारे 4 बुक. येलो बुक जिसमें स्नातक छात्रों के पाठ्यक्रम, ब्लू बुक पीजी छात्रों के पाठ्यक्रम, पर्पल बुक एकेडमिक कोड ऑफ कंडक्ट और ग्रीन बुक 14 वर्षों के बाद जो रिवाइज किया गया द ग्रेजुएट स्कूल के बारे में विस्तार से जानकारी शामिल इन 4 पुस्तकों में आज ये पुस्तकें विमोचित हो रही हैं. इसकी दूसरी कड़ी में शामिल हैं हमारी 4 महत्वपूर्ण पुस्तकें. एग्री न्यूट्री इंफॉर्मेशन आर रेडी रखनर, कृषि पोषण सारगर्भित संदर्भ डॉक्टर सत्यप्रिय जी एवं उनकी टीम के द्वारा लिखित ये पोषण पे एक रेडी रखनर पुस्तक. कृषि ड्रोन तकनीकी सिद्धांत एवं प्रयोग डॉक्टर दिलीप कुशवाहा जी, डॉक्टर पीके साहू जी द्वारा रचित यह पुस्तक. प्री एंड पोस्ट हार्वेस्ट मॉड्यूलेशन ऑफ वैल्यू चेन डॉक्टर दिनेश कुमार जी एवं टीम के द्वारा लिखित ये 4 पुस्तकें आज विमोचित हो रही हैं. इस कड़ी में तीसरी कड़ी में शामिल हैं पूसा संस्थान की उन्नत कृषि प्रौद्योगिकियां टेक्नोलॉजी बुक ऑफ आईसीआर IRI. ये बहुत ही उपयोगी पुस्तक आज विमोचित हो रही है. बुक ऑफ प्रोसीडिंग्स एंड एक्सटेंडेड एब्स्ट्रैक्ट ऑफ नेशनल कॉन्फ्रेंस IPAS 2023 डॉक्टर सुषमा सुधीश्री एवं टीम की एवं उस कॉन्फ्रेंस के रिकमेंडेशंस भी आज विमोचित हो रहे हैं. साथ में 3 बहुमूल्य टेक्निकल बुलेटिन, अनार और अमरूद की खेती डॉक्टर रशीद परवेज एवं टीम, शिमला मिर्च के प्रमुख कीट डॉक्टर हेमलता एंड टीम एंड मेजर पेस्ट एंड डिजीजेज ऑफ कैप्सिकम बाय डॉक्टर हेमलता एंड टीम, ये भी आज विमोचित हो रहे हैं. बहुत बहुत धन्यवाद सर. मित्रों, जो हमारा स्थापना दिवस कार्यक्रम होता है इसमें हम लेक्चर तो होता ही है, साथ में हमारे जो कार्यक्रम होते हैं पेंटिंग और उनके पुरस्कार भी वितरित होते हैं. उससे पहले इस कड़ी में शामिल है हमारे कर्मचारी जो हमारे संस्थान के वैज्ञानिक हैं या किसी भी पद में सुशोभित हैं, उनके बच्चे जो अपने 10th और 12वीं में एकेडमिक एक्सीलेंस प्राप्त करते हैं, उनको भी इस मंच से सम्मानित किया जाता है. मैं उन बच्चों को अब मंच पर बुलाता हूं, वो कृपया करके मंच पर आए और हमारे विद्वतजनों से अपना पुरस्कार प्राप्त करें. 10वीं परीक्षा में 91.80% अंक प्राप्त करके एकेडमिक एक्सीलेंट अवार्ड दिया जा रहा है सुहानी मीना, काना राम मीना जी की पुत्री सुहानी मीना 10वीं परीक्षा में 91.8 अंक लेकर एकेडमिक एक्सीलेंट अवार्ड प्राप्त कर रही हैं. सुहानी मीना जी के लिए जोरदार करतल ध्वनि होनी चाहिए। इन्होंने 10वीं में 91.8 91.8 दशमलव मार्क्स अर्जित किए हैं। दूसरे छात्र को मैं बुलाता हूं, कृति यादव। डॉक्टर रमेश कुमार यादव जी की पुत्री कृति यादव 10वीं में 97.40% इन्होंने प्राप्त किए हैं। एकेडमिक एक्सीलेंस अवार्ड इनको दिया जा रहा है। डॉक्टर रमेश कुमार यादव जी की पुत्री कृति यादव। इस कड़ी में 12वीं परीक्षा के छात्रों को अब मैं मंच पर आमंत्रित करता हूं। मोहित महापात्रा, डॉक्टर गंगा कुमार महापात्रा जी के पुत्र मोहित महापात्रा 12वीं में इन्होंने 90% अंक प्राप्त किए हैं। मोहित महापात्रा जी हमारे साथ मंच पर आए। अगले स्टूडेंट को मैं बुलाता हूं, ऋषि अतुल जोशी, डॉक्टर मोनिका अतुल जोशी। अच्छा, डॉक्टर मोनिका मैम खुद आ रही हैं। 12वीं में इन्होंने 93.20 93.20% अंक प्राप्त किए हैं। ऋषि अतुल जोशी। बहुत बहुत धन्यवाद सर। अब मैं जो हमारे फाउंडेशन डे में स्पीच कंपटीशन, पेंटिंग कंपटीशन और क्विज कंपटीशन हुए, उनके पुरस्कार वितरण हेतु मंच में डॉक्टर श्रुति सेठी, प्रधान वैज्ञानिक, पोस्ट सर्विस संभाग को बुलाना चाहता हूं।
Good afternoon, everyone. During 26 to 28, we had organized the quiz, painting and speech competitions. So I will be announcing the names of the winners. Under the painting competition, we had a lot of students who had participated from school under the junior category from class 6 to 8. The first prize goes to Akshara Singh from Bal Bharti Public School. Students, please, I'll be announcing. You please come to the stage. Second prize goes to Kunjal from 6th class, Ramjas Public School. Third prize goes to Chavi from St. Michael's. There are two consolation prizes. The first one goes to Tanishka from AES Prasad Nagar. Tanishka sir, consolation prize, only the certificate. Chavi hai. Tanishka. The second consolation goes to Ashvi Bhardwaj from St. Thomas. So the painting competition, the topic was women in agriculture for the school students, both senior and junior categories. Under the senior category from class 9 to 12, the first prize goes to Mridul Sharma from Ramja School. Second prize, Shrestha Ranjan from class 10. The third prize goes to Mohammad Saqib from GBSSS Pusa. In place of Shrestha, sister is going to receive the award. And third prize, Mohammad Saqib. There are two consolation prizes. The first one goes to Ashne Dang from St. Thomas School. And the second consolation goes to Meet from Ramjas Public School. Please give a round of applause. This time we had participation from Dia Foundation. It is an NGO doing philanthropic work. So we are thankful to them also. We have participation from BL Convent School, Aligarh. Thanks to them also to join us here. So under the UG category, this time, the first time UG students participated. The theme was digital farming. So the first prize goes to Gaurav Chandravanshi, BSc second year. Second prize, Chandrima, BSc second year. Third prize, Nishu Bharti, again BSc second year student. Please hurry up. And there is one consolation prize, Jinsha Sherin. Gaurav from BSc second year. Chandrima receiving the second prize. All of you can see their paintings that is outside the auditorium on the board. You can just go through. Nishu is there. Third prize goes to Nishu Bharti. The consolation goes to Jinsha Sherin. Under the PG category, the first prize goes to Neha Sanyasi in painting competition. Second goes to Sasira D, MSc second year. Third goes to Pavan Kalyan KV, MSc second year. Neha is receiving the first prize. Please clap. Second prize by Sasira. Third prize, Pavan Kalyan, KV. There are two consolation prizes, Soumyajit Ghoshal and Shobik Nag. We have Soumyajit and Shobik Nag here. So next we move on to the speech competition. The topic for the junior category school speech competition was organic farming, potential and challenges. And the first prize goes to Vanya from Ramjas Public School under the junior category. Vanya is there. Second prize goes to Divyanshi Pandey, AES Prasad Nagar. Third prize, Akshara Singh. First is won by Vanya. Please clap. Second prize, Divyanshi Pandey, AES Prasad Nagar. So we are thankful to the principals who nominated these students. Third prize is Akshara Singh, Bal Bharti Public School. We have one consolation prize, Shivam from BL Convent School. Shivam is there? Any representative? आइए please. प्रधान जी आ रहे हैं शिवम का लेने के लिए. We are thankful to him कि ये बच्चों को अलीगढ़ से लेके आए. Please. Under the senior category, the title of speech competition was Role of Digital Technologies in Agricultural Development. The first prize goes to Anya Chauhan from Ramjas Public School. Second prize, Anya Malik, St. Thomas School. The third prize goes to Manan Kundu, Sanskriti School. And there is a consolation for Manisha Gautam from BL Convent School. So Anya Chauhan is receiving the first prize. Second prize, Anya Malik from St. Thomas. Third prize will be received by Manan Kundu. प्रधान जी अगेन आपको आना है बीएल कॉन्वेंट स्कूल से मनीषा गौतम को कॉन्सोलेशन प्राइज. आज बच्चे आ नहीं पाए लगता है. So for the UG students, the topic for speech competition was agri-based startups and youth empowerment. The first prize goes to Kanishka Sen, BSc Agriculture. Second, Rasila N, BTech Biotechnology. Third, Nirmal Kag, BSc Agriculture. Kanishka is receiving the first prize. Clapping should not stop, please. Second prize goes to Rasila. Third prize to Nirmal Kag. We have one consolation prize, Apurva Singh, BTech Biotechnology. Apurva is here. The topic for PG students for speech competition was minimum support prize, importance and challenge. The first prize goes to Ayushi Paliwal, MSc Agronomy. Second prize, Shambhavi Singh, PhD Environmental Sciences. Shambhavi Singh. Third prize is Vishnu Prasad, PhD Water Science and Technology. There is one consolation prize, Chandana HS, PhD First Year Genetics. So we had also the quiz competition and that encompassed agriculture, sports and general knowledge. So under that, in the junior category from class 6 to 8, the first prize goes to Saina Atul Joshi from Sanskriti School. Second prize, Divyan Gotwal, Ramjas School. Third prize, P. Siddharth, Andhra Education Society, Prasad Nagar. Saina Atul Joshi, please. Divyan will receive the second prize. Third prize, P. Siddharth. We have two consolation prizes. First is Arav Goswami, Ramjas School, Pusa Road. Arav is there. Second consolation is Shivam from BL Convent School, Aligarh. तालियां बजती रहे. Under the senior category quiz competition, school students who are receiving are first prize Yash Anand, Ramjas School, Anand Parvat. Second prize Devesh Kumar Srivastav, Ramjas School, Pusa Road. Third prize Aks Amol Solanki from Tagore International, Vasant Vihar. Yash. So first prize will be received by Yash Anand. Congratulations to everyone. Second prize Devesh Kumar Srivastav. And Aks will take the third prize. We have a consolation, Shaurya Agarwal from Bal Bharti Public School. Shaurya will receive the consolation. So first time UG teams participated and we had a huge number of students turning up. The first prize for UG student, it was a team of 2, sir. The first prize goes to BSc Agriculture, Kushagra Saraswat and Kishan Bhakar. Second prize, it's a quiz competition. First time, sir, UG students participated in all the activities. Second prize goes to Sanvi Pathak and Shatakshi Pathak, BTech Biotechnology. And third prize, Kanan Lakshay and Kumar Rohit Ranjan, BSc Agriculture. Kushagra and Kishan. Kindly clap, please. We are thankful to the coordinators for nominating the students to participate in the various activities. Second prize, Sanvi and Shatakshi, BTech Biotechnology. Third prize, Kumar Lakshay and Kumar Rohit Ranjan, BSc Agriculture. For the PG students, we had a team of 3 students in each team. The first prize goes to the team of plant pathology, Prajwal Rai, Ish Prakash and Likhan Kumar Acharya. Second prize has been won by entomology, Vidya Madhuri, Ritik Sarkar and Saurav Chakravarti. The third prize is for microbiology, Aravind Rajan, Prajwal and Manoj. So we have the first prize winners on the stage, Prajwal, Ish and Likhan. Team entomology, Vidya, Ritik and Saurav. We should clap for their hard work, please. Team Microbiology wins the third prize. Arvind Rajan, Prajwal and Manoj. On the occasion of International Women's Day on 8th March, the students had organized a poster competition and an elocution contest. So the poster competition, the topic was celebrating women's strength, breaking stereotypes. The first prize has been won by Iram Fatma, M.Tech student. Second prize goes to S. Saloni Pradhan, UG first year student. Saloni. Third prize has been won by Sasira D, MSc second year. And it is in sharing, the third prize is in sharing. Sasira and Tanushri both share the third prize. For the elocution competition, the topic was honoring everyday women's unsung stories. So the first prize in elocution goes to Rasila. Rasila N, UG second year student. Simran Pundir, MSc second year, bags the second prize. And Ananya, PhD second year student, grabs the third prize. Sir, although we organize the painting competition for 6 to 8 and 9 to 12, but we had huge number of entries from nursery and second class students. So we are also honoring them. So I will be announcing the names, all 14 students to come up on stage, please. I have given. Elocution I have given. Volunteers. So please, all tiny tots on the stage, please. Vivan Joshi, nursery standard. Vanya Joshi, nursery. Rudra KG. Avni Tiwari, first class. Ayonya, second. Anvi Chauhan, second class. Utkarsh, third class. Unnati, third class. Pavni Joshi, fourth class. Arv Bhardwaj, fourth class. Vivan Agarwal, fourth class. Vaibhav, fifth class. Swarna, fifth class. And Naisa Yadav, fifth class. So all 14 brilliant minds to come up, please. सबके लिए तालियां बजे, बहुत छोटे बच्चे हैं, थोड़े प्रोत्साहित होंगे. कॉन्ग्रेचुलेशन सबको. Thank you, sir. these were the awards for the competitions. Thank you so much, sir.
इस कड़ी के अंतिम में शामिल है एक बहुत ही महत्वपूर्ण अवार्ड जो हमारे एडमिनिस्ट्रेटिव स्टाफ, टेक्निकल स्टाफ और एमटीएस स्टाफ को दिया जाता है, बेस्ट वर्कर अवार्ड 2024। तो मैं सर्वप्रथम एडमिनिस्ट्रेटिव स्टाफ से अनुरोध करूंगा कि वो मंच पर आए। मिसिस मधु बाला, एम्प्लॉय नंबर 30769, असिस्टेंट पे बिल सेक्शन, इनको बेस्ट वर्कर अवार्ड 2024 का दिया जा रहा है अंडर एडमिनिस्ट्रेटिव स्टाफ कैटेगरी। Mrs. Madhubala, Pay Bill Section Assistant. Best Worker Award 2024 under Admin Staff goes to Shri Manish Kumar Jain. Shri Manish Kumar Jain, 30803, Employment Number, Private Secretary, Directorate. Shri Manish Kumar Jain, Directorate, Best Worker Award 2024. Under Technical Staff category for the Best Worker Award 2024 goes to Kana Ram Meena ji, 21270, Library Assistant T2, Division of Library. काना राम मीना जी मंच पे आए। अगला अवार्ड इस कड़ी में शामिल है टेक्निकल स्टाफ कैटेगरी में श्री मनोज कुमार जी 20964, सीनियर टेक्निकल असिस्टेंट एग्रीकल्चरल इंजीनियरिंग। श्री मनोज कुमार जी। बेस्ट वर्कर अवार्ड 2024 अंडर टेक्निकल स्टाफ श्री मनोज कुमार, सीनियर टेक्निकल असिस्टेंट एग्रीकल्चरल इंजीनियरिंग। अगली कड़ी है एमटीएस स्टाफ फॉर द बेस्ट वर्क अवार्ड 2024। अवार्ड गोज टू श्री देशपाल जी 41782, एमटीएस डायरेक्टरेट। श्री देशपाल जी मंच पे जुड़े। श्री मोहम्मद इलियास जी 41702, एमटीएस एग्रीकल्चरल इंजीनियरिंग। श्री मोहम्मद इलियास जी। श्री मोहम्मद इलियास जी, एमटीएस स्टाफ एग्रीकल्चरल इंजीनियरिंग। श्री विनोद कुमार जी 42048, एमटीएस डायरेक्टरेट। श्री विनोद कुमार जी मंच पे जुड़े। जोरदार करतल ध्वनि के साथ स्वागत करें इनका। श्री विनोद कुमार जी। श्री विष्णु प्रसाद कापले जी 42070, एमटीएस डायरेक्टरेट। विष्णु प्रसाद कापले। श्री विजय कुमार जी, अच्छा श्री विष्णु प्रसाद कापले जी आ रहे हैं, मंच पर जुड़ रहे हैं। Shri Vishnu Prasad Kapleji, MTS Directorate, Best Worker Award 2024. Shri Vijay Kumarji, 41534, MTS from Division of Genetics. Shri Vijay Kumarji, MTS Genetics, receiving Best Worker Award 2024. इसी के साथ पुरस्कार वितरण का क्रम यहां पर पूर्ण होता है.
The moment has come to felicitate our distinguished guest now. So I request Dr. A.K. Singh sir, Director IRI, to present a memento and shawl as the memory of this special occasion to Dr. Sanjay Kumar Singh sir, the eminent speaker of Foundation Day lecture. Now I request again to Dr. A.K. Singh sir, Director IRI, to present a memento and shawl to honor Dr. Sudhir Kumar Sopori sir, the chairperson of today's function, on behalf of IRI. Please have a big round of applause. Thank you so much, sir. Yes, please. Now I request and invite Dr. R.N. Padaria, sir, Joint Director, Extension IRI, to present a word of thanks. Thank you.
Honorable Chair, Professor Sudhir Kumar Sapori, sir, former Vice Chancellor, JNU, esteemed Speaker, Dr. Sanjay Kumar ji, Chairman, ASRV, respected Director, IRI, Dr. A.K. Singh ji, the esteemed audience in the auditorium, Dr. H.S. Gupta, sir, has left, former Director, IRI, Dr. Anupam Verma ji, former Dean, and Dr. A.K. Singh, former Project Director, WTC, former Dean, Dr. Rasmi, Madam C, has left, Dr. Rajendra Prasad ji, he has also left. Dr. Gyanendra ji, Director, Wheat and Barley Institute from Karnal. And our esteemed friends, Dr. Viswanathan ji, Dr. Anupma ji, Dr. P.S. Brahmanan ji, heads of division, faculty, students, farmers, and the students from the different schools. And Honorable Professor R.V. Singh ji, who has joined online, and several directors from the IRI hub for the education program for UG and PG, the students of the different hub program. So on behalf of IRI, I extend my sincere thanks to all of you for making this event so gracious with your benign presence. At the outset, I would like to extend sincere thanks to Professor Sudhir Kumar Sapori, sir. You kindly agreed to chair this session, and I believe that from the journey of Dr. Sanjay Kumarji from SOD to bioeconomy and linking research to entrepreneurship, it was reflected with your kind presence over here, sir. And we are really honored to have Dr. Sanjay Kumar, sir, for this Foundation Day lecture. So it was so scintillating, and it is the day when we should have such kinds of research orientation so that the research outcomes should be linked with the industry and the entrepreneurship. And the different distinguished faculties who are here, and because of their love and affection, particularly Professor R.V. Singh, who was to join this event, but in the morning because of some health reasons he could not come. But he was so excited the moment he heard about this Foundation Day celebration, and he was eager to be here. But sir, your presence online, that is also having a great meaning for all of us. Dr. A.K. Singh ji, former Project Director WTC, sir, I extend my sincere thanks to you for your benign presence. And also to Gyanendra ji and Dr. Rajendra Prasad ji and all the committee members who worked day and night to make this event so successful, and in the guidance of Honorable Director sir. And the last year had been quite hectic, and our Honorable Director sir was on wheels. And starting from QRT, he moved around all parts of the country to see the kinds of development of our IRA regional station, then inauguration of the 2 centers at IRA Jharkhand, then at IRA Assam. Subsequently, he monitored the organization of Pusa Krishi Vigyan Mela at Simdega, then closing of the March season. In spite of that, he was able to monitor all the developments related to organization of this wonderful event of IRA Foundation Day. Sir, I sincerely thank for your kind guidance and enabling us to host this event. And there are different members who helped in organization of several kinds of competitive events, particularly Dr. Bhardwaj, Dr. Shruti, Dr. Ratna, and esteemed judges, Dr. Renu Singh ji, Dr. Brahmanand ji, Dr. Monica, Dr. Jasdeep, Dr. Amrinder ji, Dr. Dinesh, Dr. Atul, Dr. Rashmi, Dr. Archana. And this event would not have been possible because of the logistic support extended by our Joint Director Administration and Rohit ji and the Finance and Audit section. And I'm also grateful to the farmer friends, particularly Sanjay Divakar ji, Pradhan, and who brought children on 2 days to make them participate in the quiz, debate, and the painting competition. And he is himself over here. And it was a kind of challenging situation for them how to face with the students, those who are from DPS or Ramjas and Sanskriti school, but they fared well. And that is a kind of beauty of this event where we promote agriculture science diffusion among the school children. I'm also grateful to the different colleagues, particularly the members who prepared the video under the guidance of Dr. Gurjesh Mehra and the members from the photo lab. And Dr. Gyan Misra ji made this movie so excellent by his editing and putting his own kind of contribution. I'm also thankful to Dr. Atul, Dr. Gyan, Dr. Satyapriya ji who coordinated this visit. And Dr. M.S. Saharan ji has been coordinating all the kinds of the distribution of the cards and also welcoming the guests. I'm also grateful to Dr. Siroi sir who brought wonderful gifts and also coordinating the food and other logistic arrangements. So I once again extend my sincere thanks to all who have contributed for this organization of this wonderful event, and we look forward for your kind presence in the cultural evening today in the evening from 6:30 p.m. and we cordially invite you for lunch in Ganga Industrial Guest House. Thank you so much. Thank you all.